Hi guys, this video requires just a little introduction before we start. So this is the repair of a powered mixer and it's stuck in protect mode. The basis of this video, and it's long so I've actually split it into several chunks, is to show you how I will tackle a repair on a piece of equipment I've not worked on before or I'm not very familiar with. Okay, I have actually seen one of these before a long time ago on the channel, and I do use that information at one point to guide me a little bit, and you'll hear me mention this in the video quite clearly. Now, if what you're interested in is how to fix the protect mode fault, then you can skip to the end or wait till the final episode. I have recorded them, by the way, so it's already done. And then you will know how to fix this fault in this instance, because it could be caused by quite a few things. In fact, to be quite honest, it may not help you at all depending on the fault on your powered mixer of the same model. Okay, now if you watch this through, you'll see how I go about diagnosing this from beginning to end. By the time I reach the end, I could pretty much create a service manual how to go about repairing this type of fault, because I've understood how the circuit works, what it does, and figured out how to diagnose the fault to find what the actual cause is. Now, I know some of you guys will be very familiar with this equipment, and you'll probably be feeling quite tempted to put in the comments, say, oh Rich, it's this, or oh Rich, it's that, yeah, or do this or do that. And that's fair enough, and you're welcome to do so, but I would just ask you not to put any spoilers in here. Really, this video is there not for people who want to have a repair guide so they can say, oh, measure this, measure that, do that, there you go. This video is for people who want to be able to create the repair guide themselves, yeah, because sometimes there isn't one, and these are skills I think are very useful. Okay, so I've said enough, let's get on with the video. I'll try to keep them to sort of 45-50 minute chunks, something like that, and I will fix this in the end. Okay, so get watching, do comment, but hopefully bear in mind what I've just said, and I hope you enjoy this. Let's go. Hi guys, welcome to Learning Electronics Repair. I have a powered mixer here, Dynacord Powermate. The customer tells me this is stuck in protect mode. So this is from one of the local bars down by the beach called Dunes and Tunes, okay? Irish bar, plays some good music, to be honest, yeah. I have a resident guitar player on there most nights. So he's saying it's stuck in protect mode. I think the best thing we can do is just, well, first of all, notice that all these are really stiff, by the way. Hardly want to move, yeah, this is not a good sign. But this is right by the beach, so this is going to be full of sand, probably. Doesn't help. I'll turn those down. Master will put up a bit. Okay, let's connect some power to this and let's see what it actually does. The light bulb is in its usual spot there. Switch on. Nothing actually happened on the bulb. It is set to limit. Maybe there's a power switch actually on this. Let's just try. Yeah, looks like a power switch on the back. Push that in, try again. Oh, that's bright and stays on bright. That's a bit much, to be quite honest, that. I mean, this will draw some current, but yeah, it is going a bit dimmer. He says it's in protect mode, so what do you think? Shall we just try without the light bulb in? Well, he's obviously had it powered up. Yeah, so let's just try it and see what actually happens. Take the light bulb out. So it does power up. It was just drawing a fair bit of current, and we have protect. Okay, so it's doing what he says it was doing. Let's have a look inside and see if we can spot anything obvious. After removing far more screws than seems strictly necessary, I've got into this, yeah, and we just find another big piece of metal. I've opened these things before, so I knew that would happen. I need to get these ribbon cables off, and then we can get a bit further in and have a look to see if we can spot any obvious problems with this. Well, after removing even more screws, I'm now inside this. I've unplugged the mixer panel. I'm just looking at these capacitors. They're very grubby. I don't think they've leaked though. I don't think really these sort of capacitors tend to fail particularly. You see that? I think this is just effectively dust, dirt. Let's have a look. It just comes off. I mean, this place is right down by the beach, by the famous sand dunes of Maspalomas, by the Lingways. And I think that's actually what this is. Sand. It looks like it. I don't think that's come from inside the capacitor, but I just noticed it. Right, let's see what else we can figure out with this. So we have two outputs from the transformer, orange, brown, orange, and then we have more. We have green, yellow, grey, yellow, green. In actual fact, so we have a bit more. We have some fuses down here. I don't see any other fuses. So the first thing I think I'll just check is what voltages we have on here. You would expect probably with this amount of connections we'll have a plus and minus 15 somewhere, and we may have a class G amplifier here, so we may have like two different voltage rails for the amplifiers, and we may find that I would expect the grey one near the centre tapped, and then we have a certain voltage across the two yellows and across the two greens. Okay, so we can see where they go. In fact, they may be marked on the PCB, I think, having just figured it out. Yeah, so we have minus, low and minus high. We have plus, low and plus high. Okay, and then the grey one is there, which I think we can say is ground. Most power to you, okay? So this is a class G amplifier, that's why I have two voltage rails there. I'm pretty confident of that. And then maybe this is the plus and minus 15, but they're quite heavy cables. I mean, it's a fairly large mixer, I guess it's going to be drawing some current. Right. Other obvious things, maybe if the fan isn't spinning, it might go to protect mode, it might be testing the fans. They're turning freely, so they do rotate at least. Fuse is okay. Is okay. I'm just looking to see where the bridge rectifiers are. You'd expect some really big heavy bridge rectifiers. I don't see them at the moment. Not obvious. I don't see them bolted to the large heat sinks either. Okay. You would think they would be in this area. Yeah. I see 4 diodes, so this is the probably plus and minus 15. I mean, these are too small to be on the main supplies for the amplifier. I'm guessing, what's these at the front? What do you have on here? Wow. The middle two by the fuses, I wouldn't be surprised if they're voltage regulators, plus and minus 15. The other ones, well, they're not bridge rectifiers, that's for sure. Let's make some initial checks. I'm on volts AC. This is common or ground, I would say. Let's just power it up and see what it does. Well, it went to overload for some reason. I mean, there can't be that much voltage on here. Volts. Oh, I'm on millivolts AC. That's for whatever reason. It's on millivolts AC. I don't know why. I've turned the range to higher range. Let's go. 19 volts. 19 volts. What's on these ones? So the yellow ones is the low. 37. 37. This is the high. We double that. 74. 74. So all the AC voltages are there. Go to DC. Let's have a look. So maybe down by these resistors somewhere. Minus 16 plus 16. So this must be where the 15. So plus and minus 15 is present. Okay. Question is now is where are the big bridge rectifiers? So I can see the DC rails, the 37 and 74 obviously will be higher than that once it's converted to DC. I also noticed that both fans are spinning just fine. Oh, bridge rectifiers. They're underneath, that's why I just didn't spot them exactly here in actual fact. So you can see we have the high plus and minus here. Okay, and then low plus and minus here. So that's where the big bridge rectifiers are. They bolted to the chassis there. Okay, we can test those. Assuming this is ground, the center tap from the transformer, you'd expect that to be ground. Then we should see the plus and minus supply rails here. Okay, let's have a look. So I'm now on DC volts. $99. Oh, something went click there. That was probably the relay I'll show you. This relay, which is shorting out the NTC. Okay. Of course, I jumped when things go quick. Minus 99. Plus 49. Minus 49. Now I'm interested to see if the voltage goes away when I power this off. Yeah. So power off. Oops, I slipped. It's dropping quite rapidly. So that tells me two things. First of all, I don't have a short. Obviously it would blow the fuse anyway if I had a short. And secondly, I don't have an open circuit load either. So if there was a fuse somewhere feeding into this lot, which is powered from here, then it would cause the capacitors to stay charged. Yeah, you can see that in actual fact they discharge. This is now -4. This is at 23. So that's actually going down slower. What about this one? 0.4. Oh, that's interesting. So the positive high voltage supply is staying higher. Do you see that? I don't know if that's totally relevant. -1.8. 0.4. 0.4. So those are basically discharged to the same point, and this one is holding more of a charge. Interesting. That might tell us something. And what it would tell us is that something is open circuit on the positive side of the amplifier. Yeah. Maybe. Or this may just be because of the way that the Class G amplifier switches the voltage rails, but then I would expect the same thing to happen here, and it doesn't. That's the negative. Okay. Yeah, look, holding that voltage. I'll just give it a moment or 5 to discharge, and then I'm going to take this PCB out and let's have a look at all the output devices. So let's test them. Okay. If you were wondering, by the way, if these things are worth repairing, well, that's how much they cost. So I think that's answered that. Okay. We may have a schematic, Electro Tanya, whoever she is. It's a useful site though. I've never had any problems here. If I find the schematic when I download it, I do actually get a schematic. Not a robot. Download. Download. Okay, so it looks like we have a schematic as well. If this is actually the one I have. Sometimes they don't seem to quite match, but hey, let's have a look. Well, straight away, I don't think this matches mine because we can see here these output transistors are the TO3 package, and mine are not that package. They're, well, that one, which is bigger than the TO2 220, which is this one. So I'm not sure how helpful this is going to be. Yeah, this is also a layout. This is completely different to mine, so that really isn't much help, unfortunately. Here's another one. Let's see if this is the same as the one I already have. Possibly different. Okay, here's an amplifier schematic. This has different output devices, so maybe this is mine. Could get lucky. Okay, so we possibly have a schematic. While we were finding that, this is probably discharged now. Yeah, it's gone down now. So I'm going to get this PCB out and let's have a look to see what we have. Okay, I've got this loose now. This is like performing gynecology through a letterbox, guys. It's a real pain in the ass. I left this bolted in because it wasn't easy to remove at all. And I just took the clips off the output devices, or regulators they are, I would think. So the thing is, no, there's one left. Right, guys, I've got the PCB where I can get at everything now. This took far too many screws. Yeah, just to get this thing out. So what we're going to have here is the two amplifier channels, the positive and negative side. Yeah, so these are complementary pairs. This is bipolar. And because we know there's two supply rails, it's class G. So if we have a look on one of these, so this is either the positive or negative side. We can check by measuring the polarity basically of these transistors. If they're NPN, then they're on the plus side, and PNP is on the minus side. And then we'll see here we have a large diode. You see that one there. We have some transistors or MOSFETs. So this is part of the switching circuit between the high and low voltage positive, which are like 50 volts and 100 volts roughly. Okay, so what we will have is on the positive side, you can see the polarity, the diode is marked there. Okay, so coming in on this side, on the anode, will be the low voltage positive, 50, 45 on some amplifiers, something like that. And then that point there, the cathode, this goes to the collectors of all these transistors. And then we'll have one or two MOSFETs or transistors which switch the voltage rail to the higher supply when necessary. And when I say when necessary, it means when the waveform, the sine wave, is going to go above the voltage of the low supply. So it switches the high supply on when it needs to. This improves the efficiency of the amplifier a lot, so we need smaller heat sinks. Okay, let's have a quick look at that one. And if we have a quick glance as well, we'll see we have the same setup here. So again, we have a diode there, a bit hard to see, but it is there. Okay, we have in this case one transistor, probably the switchy one, that I'd say is something else like a temperature sensor. Okay, and then we go again, so we can see here, yeah, there's the diode and one transistor. So that tells me basically that whichever way round these are, these two are both the same polarity, NPN or PNP, because the layout is the same. And I'll imagine that one is the same as this first one. Okay, let's have a look. So yeah, we have the extra transistor on this one. The diode is, where is it? It's going to be, yeah, that one with 2 pins on. Okay, looks like that was 2 pins. Hard to see from this angle. Oh, the diode's here behind this little red capacitor. Okay, so we sort of know what we have. I think we have a schematic for this, but let's just make some basic checks while we're here. So I just want to look for any short circuit output devices and anything around this diode, because the fact that the main capacitors are not discharging evenly makes me think that part of the circuit is where we have a problem. Okay, we may well find that one polarity, NPN or PNP, of one or both channels has, for example, like plus 45 or 50, but the minus is 90 or 100. You see, so they're not balanced, and that would cause a protection error, but it wouldn't blow any fuses. Okay, so we'll go down one of these outside ones first. Let's figure out if it's the NPN or PNP. Now I'm on diode mode. These are the big devices. There's 3 there, there's 2 more here. If they're all in parallel, then they're the output devices. We can soon find out if they're all in parallel, because the collectors will all be connected together and the emitters will all be connected together. So collector is the middle, goes to that one, goes to that one, and these other big ones, collector. So they're all connected together, and then the emitters, emitter, emitter connected, emitter, emitter, emitter. So they're all in parallel. So we have 5 devices on the output stage. Those are your output transistors. Let's just check them now. So this is always the same layout: base, collector, emitter, base, collector, emitter. Okay. So if the NPN with the red on the base, we should see a diode junction to the collector, and we do. And to the emitter, we're going to see a low reading because there'll be a base emitter resistor. Yeah, it says 37. Yeah, it's not a short. We go to ohms range. There's probably a 47 ohm resistor. I think that's fairly common. Yeah, like 49 ohms. So a 47 ohm resistor. That is very common value. That's why I guessed what it was really. And again, the next one will have the same. So base collector, like a junction, this will read low. And collector emitter should read open. Well, it's reading 1.5, and that's with the positive to the collector. Okay, I would have thought that would read open, but we can check against the other channel in a minute. So here's another one. Okay, low reading. These will all read the same because they're all in parallel. Okay, go here. Okay, the low reading. Yeah. Yeah. Okay. Again. Okay. Now, if we measure on the other NPN side, which we know is the outside ones are the same. We already know that. So we should see the same sort of readings. So on these, base is on this end, okay? So the base is now on that end of the transistor. Opposite way to this end, okay? Physically opposite way, right, okay. So base collector reads like a diode, and this reads that low reading, the 47 ohm. And we put the positive on here, and that reads the same. So whatever I'm seeing this on both channels, okay? I thought that might read open actually, but it doesn't. And they all read the same because they're in parallel, as I said. Yeah. Okay, there's 2 more of those things. Here we go. One here, one here, the low value here. Okay, and the same with this one. So these devices all read okay, they all read the same. Yeah. Now let's look at the PNP transistor. So that's going to be on this one. I think we can say they will be PNP. I mean, you can have an amplifier which is all NPN, for example. Okay, and we can see that this end is the base. Okay, so these should read in the opposite polarity if they're PNP. Okay, so if we put the red on the base, we shouldn't read anything. We don't. We have a reading, but it's not a diode junction. That is obviously the low value resistor, so it's either way. Put the black on the base. If we get a diode junction, we do. These are PNP. And so with the black to here, reads about the same as all the others. Okay, that's black to the collector. Okay, because the collector is more negative on the PNP. So again, diode junction, low reading, that reading okay. The fact I'm getting that reading everywhere tells me it's probably okay. Low reading, that one. Two more up here. That one, low reading. Okay. And the last one is here. So they all read okay, the same as each other. And then we have the last ones, which are, you can't see from that angle. I can see. So on these, this is the base, okay? The side towards me. So again, physically the other way around. Let's check these. Black to the base then. Diode junction reads low. You see that funny reading. Okay, same. Yeah, same. And then the other two are over here. Okay. Right, so all the output devices read okay. Now we've got the transistor or MOSFET next to the diode on each. Yeah. Which we can see the diode is this one. Two legs, one by the red capacitor, okay. So the diode is here. That reads 0.369, other way. That's climbing up a little bit. Yeah, not a diode junction. So let's compare that with the one on the other side. The NPN side, which is here. I can see where the diode is. 0.37. And climbing up. 86, 87, let's do the same thing. Yeah. So this is a capacitor charging somewhere about like 1k now. Go back to this one. All the way around. Yeah, so they read the same. Okay, so that's those. And then we have the ones on the negative side. So I can see one of them is here with 2 pins. Reads like a diode. We see this reading climbing up. Go to this one. Reads like a diode. Climbing up. Okay, so those read the same as each other. So far I haven't found any difference then. And then we're going to have a MOSFET here. So in fact we can see here. Just by looking at the tracks we can see. Okay. And then we'll check if this matches our schematic. So here is a MOSFET. Can you see this? This is coming in from one of the large bridge rectifiers into this MOSFET, and then out of it is going to here. Okay, and then we can see another one coming into the diode. Are these points connected to each other? Yeah, this point is the same here. Okay, so that will come down from one of these bridge rectifiers. Okay, and then we go out the other side as well. So those MOSFETs are definitely switching the voltage between the two rails. Okay, let's look at these MOSFETs. All transistors, I mean, they could be either, but I suspect they're probably MOSFETs. So if these are MOSFETs, this would be the gate. Should read open to here. Oh, we get like a highest reading. Highest reading. That's climbing up. And then the opposite polarity should be a parasitic diode. Yes. Okay, so that's one. The other one is, well, there's the diode. So yeah, this is the MOSFET. I see the big heavy track coming to it. So this is probably P channel. Opposite way around to the other one. Parasitic diode that way round. Okay. That needs just climbing up. That means like a parasitic diode. Back to the other one. Parasitic diode. Yeah, just climbing up. And then we go on the other side. Let's have a look. So there's the diode. This must be the MOSFET again. You see that big heavy track coming in from the bridge rectifier. This I think is the gate on this one. Soon find out. No, that must be the gate, this one. Yeah, reads a high reading. Reads a high reading. This is the parasitic diode where the gate, source is more positive than the drain, which is the reverse polarity, and this will be like just climbing up. Okay. And then the negative side, again, we can see the diode, so the MOSFET is probably that one, I would say. Yeah, big thick track coming into it. Again, so we know the gate is here. That's just climbing up. Climbing up. Find the parasitic diode. There's the parasitic diode, so this must be the gate. We can soon check by just looking where it is. Yeah, it's there, and this end is the gate. That makes sense. There's the diode by the capacitor again. So all that basically reads okay. Let's have a look to see if the schematic actually matches what we have here. Okay, so this is the schematic I have. Let's see if this matches our amplifier. So we can see there are 5 output devices, NPN and PNP, 5. Port number MJW21195 and 21196. And they numbered like, look, Q321, 3, 5, 7, 9. And then these are 2, 4, 6, 8, 0. Okay, so we see how they're numbered. Let's look at our amplifier and see if it matches that. And we may be looking at the other channel, by the way, so same thing, but Q121 to 129 and 122 to 130. Right, what do we have? Well, we have the right device, MJW21196. And we have 5 of them, so this is looking promising. Oh, Q129, 125, 127. Yeah. And we have 1, 2, 3 and 1, 2, 1. So that actually matches. And then these would be the even numbered devices under here. Yeah, 1195, the other device. This is ours, Luke. It matches, yeah, Luke 126, 130 and so on. So that matches our design. Let's have a look at these diodes. So we have the diode is there, D123, and we have Q1 something 7. I can't read. Other side. D122 and Q146. I bet the other one's 147. Let's look. MOSFETs. Oh, I bet they're over here somewhere. Here's your power coming in. So we get, yeah, 52 and 104. Minus 52 and 104. This looks like it. Yeah, see the MOSFET here. 147, 346. So 346 is the N type, and this is the P type. No, actually, they're both the same type, actually. Okay. MOSFETs conduct both ways, fair enough. Yeah, 146. We know that was one of them, 146. So the diode will be on one of the... Oh, it's there. Look, can you see this, guy? So we have rail plus B and rail minus B. And then we have the same for channel A. Rail plus and rail minus. Okay, and it doesn't specify a voltage because it switches the voltage. And if we look at our amplifier, look, rail plus B, rail minus B here, and then rail minus A, rail plus A. So that's the supply to the output devices. Okay, the driver always runs from the plus and minus 104 all the time, so these are the ones that actually switch. All the rest of this loop runs from the 104. This is the input side of the amplifier. And then coming into rail A plus, we have U2 and U3. U2 comes through the diode and U3 comes through the MOSFET if it's switched on. And we can see those here. If we look at the thing, yeah, look, U2 is a 52 volt, U3 is the 104, and there's the negative side of it. So what happens here is rail plus A and rail plus B by default are 52 volts via this diode. When this MOSFET switches on because it decides it needs more voltage for the output stage, the diode is now reversed bias. This end is more positive than this end, so that can't conduct. So the 104 can't go back down into the 52. That stops it, okay? And we see the same if we look at the negative side. So again, here is the 52. That is rail, and this is the minus U3, which is the minus 104. Yeah, U3. So you can see how this works, guys. And then obviously the same for the other channel. Right, so far we can't find any obvious problem. The MOSFETs look okay without taking them out of circuit. The diodes read okay. So I think what we need to do is power this up and have a look to see if we have plus and minus 52, because that's what we should have with no input, okay? And the other thing we need to check is to see whether we have 0 volts on here. So this is the output from the amplifier, channel A, you can see here. This is the output, okay, which goes to the relay. This is the relay loop. So we need to look on there. That's all the emitters, okay? To do this, I'm going to have to put this back together to some extent. But really, that's the only way I can see we're going to test this. I've basically connected this all back together, but I can get to where I need to. It's easier to get to the positive side because there's a big gap here, but I can also get down to the negative side as well. But I may not need to. So if I check on the collector on the output transistors here, I should see 45. It's on resistance at the moment. That way I know I've actually got a good connection to ground there. Okay, so we go to volts. They're a bit more fiddly on this side, but I can get down to them, so there should be the minus supply. And the other one I'm interested in is what's on the emitter. But basically all these emitters are connected together as long as the emitter resistors are okay. And actually I didn't test them is an honest truth. Yeah, perhaps I should have done, or maybe I will next. But first of all, let's have a look to see what voltages we have around here. I have to measure the output voltage on the emitters because the speakers will be disconnected while it's in protect mode, so that's not going to help me. Now let's power this up. And what do we have? So, collector, 48, so that's on the low voltage you'd expect it to be. Emitter is 0. Come to this side. Collector on minus 48, emitter is 0. Collector minus 48, emitter 0. Can I get to these because the mixer's in the way? Yes. Collector plus 48 and emitter is 0. So that will actually read okay. I think something's actually warming up on this. I mean, I don't have the heatsink mounted on all these devices here. Let me get the thermal camera. Because it's not drawing any power, I didn't think anything here would get particularly hot. I could be wrong. Yeah, there's a bit of heat coming down here. I may have to put the heatsink back on. Let's have a look, see where there's warm. So something down here, this one was very warm. It's at 54. Yeah, these are all quite hot. So I'm going to let them cool down. I'm going to put the heatsink back on this and then try it again, okay? Okay, I've put the heatsink back on. Yeah, I thought with no load it probably wouldn't make much heat, but if they're all dropping voltage, I guess they're dropping voltage, yeah. So let's see, we'll power this back up again. Okay, and let's see if we can see anything getting warm that shouldn't be. Well, this transistor here is now only 60 degrees, that one. And this one also is about 60 degrees. That's the two bigger ones. That's also fairly warm, 60 degrees. Something here is rather warm also. There. Looks like a diode. And another diode, okay. So switch this off a moment while we have a look to see what we have. So it looks like these diodes down here are getting hot, and especially the larger ones of these devices. I wouldn't thought the diodes should get hot. Let's have a look to see what we can read down here. Okay. And then we'll take some voltage measurements, I think. So these are the diodes. Yeah, this heatsink is really quite hot, quite warm, that, yeah. Generating some heat. Right. So these are the diodes, there's 4 of them. I'm pretty sure this will be effectively a bridge rectifier with 4 diodes. And this is probably generating the 15 volts, I would imagine. So we see them down here. Okay. Well, that reads strange to me. It's now climbing up. There's probably some voltage down here somewhere. Let's see. Only about 0.2 of a volt. Okay. Go again into diode range. So let it climb up a little bit. That reads like a diode. Also reads like a diode all the way around. Passing through 0. That's just climbing up. This is reverse biased. Let's go with the other 2. In fact, I'm going to just disconnect the 15 volts from the transformer. We can get here more easily. So from here, this has a bit of a strange reading. This one. .489, this one. Again. 512, okay. Have a look at these 2 transistors that we're getting hot. So we can see here this is the base. Base emitter reads low, but it could just be a low value resistor. That is climbing up again. Doesn't read, well, yeah, it's going to, look at that. Maybe this is a PNP transistor. That reads more like a junction, but it's a bit lower than I would have thought. This one, that low reading again, what's that tell us in ohms range? $34, $35. That was the other one. Just the same. Similar, a bit lower. Okay. Let me see if I can find these on the schematic and see what these are supposed to be and figure out what's going on. But to me, they're running too hot. The same with these diodes. So we have Q13 and Q14. Well, we can see them here. Those are the diodes. We have Q13 and Q14. So these are 24 volt in and should give 15 volt out. Oh, in fact, there is also a LM317 and 337. So that's also a voltage regulator. They seem to give different voltages. So we have plus 15 VM and minus 15 VM. And then we have plus 15 volt and minus 15 volts. So these are different voltage rails. Okay. Let's see if we can just measure the resistance from the collectors of these to ground. And also the outputs on the LM317. Which is 2, the middle one, and pin 3 on the 337. Let's just check some resistances here. So measure to ground resistance range from this one. That reads high, kilo ohms, okay. The other one goes into the kilo ohms, and then the 317 and 327. Okay, I've had to turn this around so I can actually see them. We have, if I can get it to focus, LM337 and LM317, okay? So connect to ground, LM317 pin 3, reads open, pin 2. That's reading a funny negative reading, like again we've got some problem with a capacitor charge somewhere. Okay. I don't see any shorts here. I think what I'll have to do is power this up yet again. And let's see what voltage we have on all of these. I've just thought, by the way, these are probably supplying stuff on the mixer, so I think I need to reconnect the mixer board and measure again on resistance. And while we're here, let's just check these diodes again. Hopefully the capacitors have discharged. So that reads like a diode. Yeah, that one too. And that one. Yeah, they all look like diodes, so that's good. Let's connect the mixer board. What do we have now? Back onto resistance. Okay, this will do for ground. There's no short there. No, I'm not seeing any shorts. I'm surprised it's running this hot. This will be the negative supply. Do it the other way around. Okay, don't see anything of a problem there. Okay, so we have to connect this back up and measure these voltages on these and see what we have. Okay, I'll just put the heatsink back on. So on the collectors of the transistors, we should see 16 volts. Okay, plus and minus. Let's find out. 16. This is the negative side. What do we have? Minus 16. Can't even get to these LM317s. Yeah, I'm in there. So it's pin 2 on this one. This is the negative one. Minus 23, maybe it's not pin 2. I think that was one of the inputs I was reading on here, okay, which is, oh, well, it's pin 2. Yeah, it's pin 3 on the negative one that's the output. Okay, and it's pin 2 on the positive one. Okay, let's have a look. So, collector minus 16, pin 3, minus 16, collector plus 16, pin 2, that all put together, what we're in, pin 2 plus 16, it's about 16 rather than 15, but let's try again with the thermal camera. Well, these are 40 something degrees actually. 45. That's the diode, so it's not stupidly hot. $62. The voltage regulator actually is quite cool. 70 about, and the voltage regulator is again quite cool. The voltage regulators are cool, so it's nothing to do with them. It's these things, they just run hot. Anything else getting hot down here? This one, that's about 86, that one.